Hi, so we want to talk about the incredible engineering in some of these tools, how they're put together and what we can learn from seeing what's inside. So I'll take this apart and skip past this place. So, last fixing out. We'll see what's inside. I should remove this chunk first of all, and we'll carefully pry it apart. I believe these buttons might get in the way very slightly, but let's see what we can find. I haven't taken this apart before, so if I may have nope, I think they're all out. Let's just try it. Push it very slightly. It's always a good sign of a well-made tool. Maybe it needs a little persuasion here. As we thought, there's a very small sticker here, which is actually over the cut line. So I assume that's an anti-tamper device there from the Germans. So let's see if we can possibly pry that without actually cutting it. But I don't think we'll be able to do that. Let me see. There we go. I wonder, can we peel that back without damaging it too much? Because this tool is officially still within a warranty, and we would like to keep that if we can. So, actually note here that most of these tools used to be made in Germany. They've now outsourced to Czech Republic, and again, actually, this is an 18+3, and when we were searching for it, we did planned to buy this specifically because it was made in Germany. Disappointing that they've changed that. So let's open it. Hopefully slightly easier now. And we'll see what's inside. Let me move these out of the way. We will need these for the next episode, where we plan to take this apart, which is quite an impressive piece of engineering. So let me move this across and we can have a look exactly what's inside. Some of you may have watched another YouTuber called AVE, and he's quite impressive in his teardown videos. So I thought I would replicate some of these with more European tools, and just to show the level of detail that's involved. So you can see here we have a PA6, so glass reinforced 30, and TPE, so a TPE overmolding, which is this softer material. Again, it is quite nicely colour matched, albeit with a colour scheme that they've chosen, but it's very well done. And you can see the detail around the edge, where they've actually continued the TPE right into the edge. And then the mating surface of the tool is inside that, which is set back from the edge, which means that whenever the two clamshell halves are moulded or nested together, you get a nice continuation of this soft TPE material. Rigidity is quite phenomenal for what it is, and there's quite a lot of bracing here to help that. Again, quite a lot of air holes in it for ventilation. Even though that it is a brushless motor, it still needs to be ventilated. A little bit of marring here from modifications to the moulding tool, especially here. You can see the witness mark of where the injector pins, well, actually either injector pins or probably where the sprue was joined and had to be cut off. Another brass insert, which is quite impressive. Again, that's visible on the outside as a boss for the attached holder, which can be screwed into that, which is actually much better detail than some of the other Festool tools that I think, which is probably what this used to have been. Let's see, what does it show on the inside? No, where they actually have a plastic belt clip, but this is much superior. Again, there are locating pins to stop the belt clip rotating, so it's quite impressive here. Now that's interesting. There seems to be some sort of material there, and that lines up with on this side of the tool. Ah, okay. So it's just that contact is where this slides back and forwards, and that engages the different gears. So let's just allow that. There's an impressive amount of weight in this tool. That's that side. And then we can look closely at this side. Again, it's quite well done. So we will take apart the pieces that we can do. Sorry, I'll move this across. So we start down here at the bottom. There's actually just a piece of paper, surprisingly. Let me put this in the middle, which is holding this part in. Ah, okay, so that's just a small prism where the light from 3 small LEDs transfers. I wonder, can I take that out? that's very clever. So the prism has actually got a tail in it, which nests within that. That's very well done. That's very well done. Now let's see if we can take this. Let's see what parts we can take out now without. I think these will come out. So that's the selector switch, and there's actually a metal dial in there. Now I wonder what that is for. If we set that in again. So that's impressive. So whenever the tool is open or enclosed, this is what selects between drill and screwdriver action. When we take this out, there's a small spring clip, which I must remember to put back in. But again, this metal dial, I shall show you that closely. There's actually a small Hall effect sensor, which is an incredibly useful tool because it's non-impact, so it will not wear over time. I shall leave that there and slowly take this apart as we can. So other parts, again, the selector switch from, and again I think this, it does. You might be able to see just here a small, another Hall effect sensor, which is very impressive indeed, and another small spring clip just to hold that in place. So again, I should remember to put these together so that I can put this tool together. Ah, that's clever. Another part is this, which is a very small LED. Again, it's an LED with a prism in front of it just to increase the spread. Let's take these one at a time if we can. So we have another molding here. Again, ABS, an incredible detail into how it's done. This is, again, this is the torque dial that's used. Sorry, I should bring this in slightly. This is the torque dial that's used. On this tool, there's an electronic torque control. I wonder, can we take this out? I hopefully will try not to break this as it comes out. So again, another molding, PA6 glass reinforced 30. And a very small control board. Again, there's a spring clip holding this in, and there's, yes, so this is, shank is D-shaped in profile, which interlocks with this rotating disc, and I assume by the contacts that are shown there that's another Hall effect sensor. So let's take this out. I'm surprised to see this exposed copper wire around the outside of it. I'm suggesting it's probably a heat gauge of some sort. Right, let's see if we can take this out slowly in pieces, just so that it doesn't completely fall apart. I'm going to move this off to the side now, just so that we can remove most of this, hopefully, in one piece. As we want to break none of it at all, of course. So again, we'll look at the other side of the clamshell. So I thought these were alignment pins, but of course they're not. These are magnetic. So when the two sides of the clamshell are closed, these provide a location to magnetically hold screws or driver bits. Again, just closing the clamshell with nothing inside it. It's incredible that detail we mentioned earlier of how close these shut lines are all the way down. Of course, this is quite an interesting place for shut line, of course, because this is where your hand is most of the time. So I probably would have liked the shut line to be brought around the corner, but again, if it's enclosed in such a good way, then maybe that's not a problem. Again, all these bearing surfaces are incredibly thick. A strange detail here, which is different from the detail here. I don't know why they would change that. I suppose it allows more room for the potted control board. It is incredible, the detail that's gone into that. And again, another thing to pick up from Eve, if any of you've watched it, it's a brilliant YouTube channel who does a similar thing to this again. The stickers, they're actually aligned properly. I should check this one as well. It's nicely aligned. Now, of course it is within a recess, so you would expect that, but I'm sure the Germans have designed an alignment tool which probably catches these marks and sets the sticker exactly in the middle. Now we should look at the rest of the controls. Maybe just turn them over first of all to see if there's any names. Interestingly, so this is all seated on a board. Oh, and there is the very small prism that's fallen. I shall keep this here. So I suppose everything's on a board to allow for secondary, well, assembly in components. I wonder, there's grease everywhere here. So again, these, I don't think this is actually, no, it's not connected at all. It's actually held on by magnet. That's quite incredible again. So there's a very small magnet there, which is used to align this bracket. And then this is held on inside. Now, so this is a potted board. An interesting use of large surface mount capacitors. Normally you would see on some of the other ones we've seen as a lot of through-hole capacitors, but so it must be a fairly impressive board under this. I wonder, does anybody know in the comments how we can remove this potted surface without destroying the components underneath it? I think that would be interesting to try. Again, these have been potted in completely, so there's no method of these coming loose in time. It waterproofs the surface as well. And again, as you follow these up, these have been welded or soldered on. On both sides. Now, I wonder, can we actually take these two parts? I would suggest we can, because these are shown as actually two separate plugs. So I wonder, can we take these plugs out and actually remove these two sections? Ah, interesting. So we have the motor housing at the back, and that drives straight into the planetary gear arrangement. I wonder if I can carefully take this clip out. I want to pull straight up on this, not actually. Yep, there's. So the pink wire, remember, is on the inside. And we will take the red wires out now too. These are incredibly tight connections. I'm surprised there's no additional silicone to hold these in, which you would maybe expect. So again, let's look at the actual gearing first of all. So we can see a emitting surface there. Material wise, this does seem to be two different components, where this is held within the clamshell, and this is the rotating element. Again, let's see if we can get this gearbox to work. So that's actually locked it out. Now I wonder, is that because of the electronic controls that it, but there's a physical drop there. I wonder, can we get in any deeper than this? Ah, so this is loose, and it seems to be held just here at the top. Now, let's carefully go in slowly here. I hope you can see from. So, again, we have an impressively made part, which is held within these. Now, it's difficult to see if this is a sintered part or actually machined. I have a feeling it's machined. It does seem to be a singular component, so it could be a casting. It's impressively heavy. Actually, there's a substantial weight to this. So again, let's see how further we can go within this. So we have our gearings, so our planetary gears. Interesting, non-magnetic. And again, these are 2 components. I should really have a microscope here to see if these are ground or not. I have a feeling that they are. Again, there's a lot of what feels like quite high quality grease. It is black, of course, so there's a good chance it's full of molybdenum. No. So we have a small shim here. It's an interesting addition. I wonder, is that an additional element because there was a wee bit of axial movement that wasn't needed? Again, this tool has been used, but it's been used in controlled environments, so it hasn't been in any way abused. And I would say it's maybe 2 years old. Again, another incredible part. These have actually been rounded off on the inside. Again, an awful lot of grease. The grease seems to be different in here. It's maybe a higher temperature grease. It's a pink coloured grease. I don't know if you can see that. Let me see if I can. You can see that there. So I wonder, is that a higher temperature grease? Again, separate components here. Colour is very silver, so it's not a brass bushing. And again, these are incredibly heavy, dense, small pieces, so I would suggest that they are not centered. You can actually see the addition of these locating pins have been driven through the part afterwards. And the circumference doesn't seem to have changed, so I wonder, was it placed when warm and allowed to cool? So we can see the actual control board here. And again, I will get tweezers maybe next time. So we can see that what this does is lift. Yes, it does. It lifts this up and down. So I'm wondering if these pinions align with this. Let me just try that. Of course I won't be able to get this back in again. But if this sprocket aligns with that, then these will spin and this will not transfer the load on through. Let's see how far we can go here. So these are actually very slightly thicker and a different pitch, which means a different ratio. Very, very slightly different. But it must just be enough to change the gearing ratio and therefore the torque. There are many tests on YouTube for this drill and other Festool drills in particular. And I think the underlying design consideration of these tools is not necessarily the outright power, but more the finesse and control. They're usually used with kitchen manufacturers and so forth who are more interested in being able to control the fixing and the depth that anything should be inserted rather than outright power, which some of the other manufacturers go with. It is impressive to see no plastic parts. This is tricky to get out. Let me just see if I can scoop it up. Again, it is so incredibly tight tolerance wise that it's not allowing me to move it. Ah, sorry, I know. This pin needs to come out. I suspect it's just a hooked pin in this side, and again this side. So that should allow it to come up there. That's why it wasn't coming out now. So yes, right, a track the right way around it. That's impressive. Of course, because this has to spin. So if it was a single drilled hole, then that wouldn't work. So this actually spins on that, which is why again there's so much grease around it. Again, these do not look like sintered parts to me. There's a definite density to them. Now, we must be getting near the again, the amount of parts in here is quite impressive. I wonder, there's another set actually of gears in there. I don't know if you can see. Let me just turn this upside down and see will it come out. Oh wow. So we have another roller bearing. We have another magnetic. We have another pin, which was in here. Okay, so that's another assembly right at the very head. is this actually it's not a compaction of grease, it's just another locating pin. With, again, more metal the whole way through the drill. You can hear the amount of grease that's there. Again, it seems to be more of the pink grease with maybe a little dirt in it. But no actual burring here, no burring surface. No roller burring. This has now jammed up for some reason. I wonder, was that not meant to be in there? So you can see that that's not moving at the minute. Let's see if I can get this one out too. Ah, there's another. So I thought it was strange that only two of them had a small steel pin in it. So that's very, very smooth. And I'm not sure what that's actually running on. Is there a bearing in there? I think this, don't know if you can see down there. I think this is a bearing surface, or an actual 600 series bearing, because it is very smooth indeed. You can see how effortless that is, and it's incredibly aligned. There's no axial wobble there at all. And unfortunately I can't take that out because I think there is a spring clip possibly. Or maybe the design of this, there's possibly a special tool which takes that apart. The interesting thing is the connection between this metal part and this overmolding. And it seems to be incredibly rigidly connected. I wonder if those mated. You can see where the geared surface, the toothed surface of that shell, and there's also a tooth surface of the plastic here as well. So I'm wondering, is that what's holding that in? Okay, let's try and see if we can put this together again. And the grease actually really helps with the assembly of something like this. Now the pins, well, these planetary gears have to, I think I'm going to take that out and set that in as an assembly, because I would suggest that's the way it's done in manufacture. Again, the amount of work that's put into this is incredible for what is an expensive drill, but so we can see how that runs very, very well. there was these that were first. And then we can set the other piece on top of it. Which I don't think interferes with anything, so that just needs to align with the gears and then drop down. Lovely. We should then put this on, which will hold all that in place. And then that needs just to it's actually not engaged in it there. Because this needs to go in just below that. So as this made it, it has gone in this side, but on the other side it is not. So there. So I set this in here. Again, this has got a little dirty with grease, so I'll give that a little wipe before we finish this. Again, this part can go in here again, and that rotates nicely. It's always impressive whenever you can take a tool apart like this and relatively simply put it back together again. And hopefully it will all still work. So this is our gear casing again, and from memory it's just located on these three small plastic tabs, and hopefully when I turn this, everything will move again. Lovely, it does indeed. So we'll keep it down there for the minute, because I think that was the easier of the two. So we're covered in grease here, apologies. Now onto the actual motor itself. That's an incredible motor on what looks like a plastic bushing. And I've seen many others taking motors apart, and they can simply pull the fan out. The gauge of copper is quite high. Let me see, is there a way of getting in here in any way? It looks you can see actually here, I don't know if that comes out there. There are witness marks on the spine of that to show that this gear was more than likely pressed over this when warm, and therefore not letting this in there. But let's see what we can remove. So that looks like a rubber gasket, just maybe to keep some of the grease away. This looks like another capping, just to stop anything. I wonder, can we get in this side of it? No, there's no obvious way in here, and the gear is quite firmly, so that axle does drive straight through that, but I think that this needs to come off this before we can get any further. And it's not going to let us in there. But it's a, so what's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. And again, it is a 3-phase motor, but the looks of it. No other markings in it, so I'm not sure if Festool actually make their own motors or they outsourced, but there's no other manufacturer's markings on it or name on it. Looking elsewhere, so that is American wire gauge 1. And it's actually, I don't know if you can see that, halogen free and branded STUDER, studercable.com, halogen free studercable.com. There are not many tools that will brand the inside of the wire that's used. So again, there's American wire gauge 3266, 125 degrees. So it's a high temperature wire. Again, 125 degrees on this wire. So it's a high temperature wire. Now, I'm wondering, component wise, is that's interesting. So the actual control switch, the trigger, is not a relay. Most of these seem to be relays, so this is not a relay. It's probably gauging by elsewhere in the tool. Another Hall effect sensor, which actually is incredibly important because there's no direct surface to surface contact, so in theory it won't wear. Now let's hope this engages again and it shows that. Now of course this must go up here to allow the connection. That doesn't feel completely home yet, but maybe that's what it was. Let's see. Of course, so this seal actually rests within this. So that will seal any grease. Yes. That's impressive. So now let's remember to plug these cables in. So who can remember which way around it was? And of course the Germans thought of that again by making the connections different. So you don't need to read a manual. It's obvious which one goes where. So all you tool designers out there, remember that. Make things obvious. Make things work one way. And again, it's interesting that all other connections are encapsulated within this potting, but the motor and the gearbox are separate and can be replaced. So that just shows the were items, which is the gearbox, are actually replaceable, and probably by your local dealer, which again is another way that most of these tools are actually sold. They're sold through dealer networks, or I suppose that allows them to charge the higher fees, but it also means that in the long term, yes, you pay more up front, but if there was something to break, you don't need to replace the whole tool. Which probably will become, sorry, I'm just trying to line this again without taking the sellotape off, but I think I'll just take the tape off because that will be easier. I just mentioned it was easy to put these in, but of course it's only easy if you do it the right way, isn't it? So if we set these two in, first of all, align that with the slot that's made for it. And then that should just so interesting as well. Also, the actual interference sorry, I had a low battery warning on the tool or on the phone. Hopefully it's continued to record. I think it has. So no, it's impressive to see that the actual, again, another wear item I would suggest, is fixed with user or dealer replaceable parts, and this is where the battery slides on, again with enclosed contacts. So let me just, I wonder what that aligns on. Ah, there's a slot at the back which this aligns with, and that's there. Then this, of course, has to engage the correct way around. Again, that's an interesting, very simple detail to ensure that those are aligned. And again, a detent, which is just this metal spring, and that's what gives your snapping detent, which is a very simple detail. And again, all these have a small you can see that I haven't done this before, but again, that slots in there, and you can see just where there's a small track laid for cable management. So let's put this back in here. And that, again, this is probably a small acrylic or polycarbonate lens, and that just rests in there. So let's put these pieces in as they go. So this is the longer tool, so let's maybe take a little figuring out But let's see, so this needs to engage with that wire. Yeah, that was very obvious when you see it. And then this. So if that is there, and suggest this just sits in here. On this side. And there is what looks like a home for it. Yeah. And then that slots in there. I wonder, does this need to go in before the tool? Let me just look at this again. I wonder, can I see a witness mark from the other side? Where this might go. There is a small indication there that that's where it sits. So I think we're correct in this. Its placement. But maybe we can understand more from its placement looking at this side. And how it might work. I will leave the spring out for now and come back to it, because I don't think it's crucial to the end use. Slide this over. Now it will be interesting just to see that the torque setting is correct when I put this together again. I don't see why actually it should be different. But again, I've probably disturbed the location of where those should be, and I do remember having to rest over the top of this. So let's put the two halves together again and see, does everything still fit? Which there's, let me set these up here and see if it snaps together again. that's a good sign. Now, let me put, you can see that the cable is definitely not in the right place, and I should have known that beforehand, but I would suggest it goes in there. And I should nest these cables in properly as well, because they have their own. I'm wondering, has that actually been caught before? So let me just place a central fixing, and that should hold most of it together. There's so much grease now. I must remember a rag the next time. So again, everything seems to work there quite well. Let me place a screw in just here where it seems to be slightly more open than anywhere else. Just to talk again about how well this closes together. I wonder, is there a cable in there that's not quite in the right place? Because this slot is slightly more open than it was previously. I shall tighten it up nonetheless. There, that's much better. I'll just put one screw in here because, of course, this is the housing for the gearbox, so if that were to open, well, we've seen how many elements are within that gearbox, and we don't want to lose any of those. So let me just put this on, and hopefully we should have some power. So again, this is the dial to change. Setting at the back. So if we bring the torque setting right down, this will be, and whenever this is engaged to drill mode, which is this side, and this is screwdriver side. So when it's on the screwdriver side, it's on the. So there we are. I shall take this off again, just in case. So thanks for watching. As I said, in the next video we will look at this, which is the chuck that allows the inclusion of some specially made drill bits. Thanks for watching.